Great morning, boys and girls. Today we're going to be finishing 4.1D, the substitution method, number 8 through 15. And then we're going to start lesson 4.1E, applying the substitution method. And we're only going to do problems 1, 2, and 4. So today, to get started, let's turn to page 17. I'm on page 17. Are you on page 17? Looking at page 17, the substitution method that we learned last class. Remember, we want to be numbering our equations, deciding which variable we want to isolate in which equation, writing those in a t-table, isolating one equation, substituting that value into the variable to create one equation with one unknown, solve for that one unknown, and then we're not done because remember, a solution to a system is a point of intersection, not just one variable. So we have to substitute that value back into our isolated equation to solve for that variable. And finally, write our answer as an ordered pair. So let's take a look at page 18. 18 says use the picture to complete the following. Let x equal circle and y equal triangle to write a system of linear equations that represents the picture. So everywhere I see a circle, I'm going to put an x in both equations. And everywhere I see a triangle, I'm going to put a y. What's the system that makes, what are the equations that make up the system? Figure that out with your group real quick. Looking at this, we have 3 circles, so that's 3x plus 5 equals 1 triangle, which is y. And we have 3 circles, 3x, plus 3 equals to 1 triangle, which is y. Taking a look at this, which variable do you want to isolate in which equation? Well, let's label the equations 1 and 2. Because the y's are already isolated, let's just write equation 1 on the left, 3x plus 5 equals y. Let's write equation 2 on the right, 3x plus 3 equals y. Now, let's rewrite equation 1, y equals 3x plus 5. Give it the bubble, and it floats into the other equation. Three x plus 3 equals 3x plus 5. Now we have only one equation with one unknown, which we can definitely solve for. First thing is let's bring all our variables to the same side. If we subtract 3x on both sides, oh no, our variables canceled out. Are we left with a true statement or a false statement? I hope you answered that question. You're right, this is a false statement. So what does that mean about our system? That means there's no point that I can substitute in that will satisfy equation 1 and equation 2. So we can say there's no solution. Explain in words how the structure of the equation supports your solution. Well, looking at the structure of the equations, what do you notice about the variable terms and the constant terms? Think about that. What do you notice about the variable terms and the constant terms? In both equations, we have, what do we have? We have the same number of variable terms, and a different number of constant terms. If you think about in an equation, the variable terms, or the x's, the coefficient of x's are, that's right, it's our slope. And the constant term ends up being our y-intercept. So what do you know about the graph if we have the same slope and different y-intercepts? You're right again. These are going to be parallel lines. Why do we know they're parallel lines? Same slope, different y-intercepts. Think about the picture of these lines. How many times do they intersect? Never. So how many solutions are there? None. No points of intersection, which means we have no solution. Great. Now let's look at the next problem. Number 9. Use the picture to complete the following. We're going to be looking at these squares and stars, and we're going to make x to be equal to every square, and we're going to be making y equal to every star. So go ahead with your group real quick, figure out a system, the two equations that make up the system. Okay, hopefully we've already numbered our equations. And the first one, we have 2x's being added and 2 y's, so that's 2x plus 2y equals 24. And we have 1x and 1y equaling 12, so x plus y equals 12. So now we're going to use our table below, and we're going to use the substitution method to solve the system. Looking at my system at equation 1 and equation 2, I notice equation 2 is going to be much more efficient to isolate a variable. So I'm going to cross out this 1, I'm going to put a 2, and I'm going to put a 1 over here. So I stay organized. I'm going to write equation 2 up top, x plus y equals 12, and equation 1 on the other side, because remember, I want to use both of my equations to solve the system. Now let's decide, do I want to isolate x or isolate y? Let's choose x. X equals, subtract y on both sides, 12 minus y. Give that a bubble, and it floats over to the other equation. So we end up with 2 times the quantity of 12 minus y plus 2y equals 24. Go ahead and finish solving this equation for y. Please pause the video now. Did you end up with a true statement or a false statement? That's right, 24 equals 24. This is true. What does that mean about our system? That means that there are infinitely many solutions. Is there something about the structure of our system we could have noticed from the beginning and saved us all this work? Well, looking at the structure of our system, we notice that equation 1 is a multiple of equation 2. Equation 1 is a multiple of equation 2. In fact, I only have to multiply equation 2 by 2 and I get exactly equation 1. 2x plus 2y equals 24. They're the same exact equation. If they're the same equation, what do you think the graph of this system would look like? They're the same equation, so when graphed, they are the, you guessed it, same line. Where do lines intersect each other if they're the same line? Intersect everywhere. That's why there's infinitely many solutions. Great job. Okay, let's get ready to turn the page. Now, remember to read the directions. Directions are really important. We're going to solve each system using the substitution method. We're going to show all of our work and we're going to write our final answer as an ordered pair. And remember, ordered pair means alphabetical order. A, B, C order. In some cases it's X, Y, but in other cases it might be B, W. So I'm going to do a few of these with you, but I'm going to let you work with your group to solve some more. So I'm going to do number 12 with you, and I'm going to do number 14 and 15 with you. So let's start with number 12. Taking a look at 12, the first thing I want to do is number my equations in the system. 1 and 2. Then I want to say which variable is most efficient to isolate in which equation. I'm going to choose B in equation 1. So I'm going to write equation 1 on the left, A plus B equals 6. I'm going to write equation 2 on the right, 3A plus B equals 15. Now I said I'm going to isolate B in equation 1. To do that, I subtract A from both sides, and I have B is equal to 6 minus A. I'm going to give that a circle, or a bubble, so that it can float all the way to B in the other equation. So now I have 3A plus what B is, which is 6 minus A, equals 15. Which is great because now I have one equation with one unknown. So let's combine like terms. 3A minus A is 2A plus 6 equals 15. My goal is to isolate the variable, so I need to subtract 6 from both sides. When I do that, I end up with 2A equals 9. And then I need to divide both sides by 2 to undo the multiplication. And A is equal to 9/2, which is a great answer. Leave it like that. Because now we're not done, we have to go back up and solve for B. B is equal to 6 minus 9/2. When I look at this, I know because I'm a mathematician that 6/1 needs to have the same denominator. So I know B is equal to 12/2 minus 9/2. What is 12 minus 9? 12 minus 9 is 3, so B is equal to 3/2, 3/2. Give it a circle, then write your answer as an ordered pair, A, B. Write your answer as an ordered pair and give it some flair. Awesome. So our answer to this system, or the point of intersection, is 9/2,